Okay, guys. So basically, today I will give you an example on how we could convert an ER diagram, whether that be Chen or crowsfoot, into UML class diagram. Now, before we start, these are the sample tools that you could use for creating class diagram. Actually, you could even make use of Microsoft Word or any text processing editor as long as it has support for flowchart and symbols. But using specialized tools for creating UML class diagram will be helpful if you are creating documentations for your program later on. In fact, some UML tools could actually generate the skeleton code for you if you will encode them in their respective software. Now, in here, I have provided three platforms, Windows, Web, and Android. You could choose whichever platform suits you and your existing device. Take note, if you are creating class diagrams, it is usually better if you have a large screen estate so that you could minimize the need for dragging your screen back and forth. But of course, if you do not have a device that has a big screen, you could always make use of the Android platform. Now, for Windows, you could install Argo UML, Star UML, Visual Paradigm, White Star UML, or you could also make use of web UML tools such as the one that we will be using today, such as the HTML5 app from diagrams.net. Could also make use of draw.io or lucidchart. Some of these sites require you to register first before you can use them. And if you do not have any available laptop or computer, you could make use of your Android device using or installing the app Draw Express Diagram Lite. Now, what things do we have to consider when we are converting ER diagrams to UML class diagram? The first one is you can already add the fields or columns to the ER diagram to make conversion easier. When I say fields or columns, basically these are the columns and the data types that are located in your particular entity. Now, let's say, for example, if you have an entity called student, the student will have a student number, which is text. It could have a name, which is text, age, which is an integer or a number. Okay, you could already input that into your ER diagram so that you could just transfer it when you are creating the class diagram. Number two, the method or action used by entities in ER diagram are usually also the methods declared for our class diagram. If you are familiar with the steps that I have discussed when creating ER diagram, take note that the action for Chen is located in the diamond, whereas the action for cruise foot is located on the side or on the top of our crow foot line. Now, those actions are actually also the methods that you will place on the third part of our class diagram. Because as you may remember, our class diagram has three parts. The first part is the name, the second is the fields or the columns, and the third are the methods or actions for that class or for that entity. Number three, UML class diagram makes use of one for one, asterisk for many, and zero for zero as its symbol. Okay, so we only make use of those three particular symbols. And number four, lines represent different relationship for a class diagram. But for most purposes, a simple line, which is the association line, will suffice. Not unless you are specifying a specific relation from one object to another. So take note of that, of those four reminders when creating an class diagram from an diagram. So let us now start. If you will remember, I have given you a diagnostic task from Unit 6, which unfortunately, I think not everyone has submitted this task. Okay. But anyway, I will run down the examples that I have given so that if in case you have not yet created this diagram, I can refresh you up on how these diagrams were created. Now take note, I will show you the diagram as a whole, meaning as an entire unit. They will not be separated anymore. So because they are integrated into one unit, some of the actions have been changed in order to reflect the actual diagram itself. So I will show you how I created this particular diagram. Now, the first example is fisherman catches many fish. So fisherman, so basically we are pertaining to only one fisherman. So the symbol is one. So we are using crow's foot. Catches one or many fish. Take note and always remember, if you have a plurality of many in crow's foot, we still draw the symbol one. Okay, this one is always required. Okay, so you cannot have a single symbol. This is always required for the symbol many. So one fisherman. So the symbol for one is two lines. One fisherman. So basically that's just one. One fisherman catches one or many fish. Okay. And then many fish are kept in many storage. So fish and storage. We could actually place the entity on the side, but as to minimize the size of our diagram, I chose to put this below the entity fish. So what happens is that the action will go from fish to storage, not from storage to fish. In doing so, we are also changing the particular verb. If we will not change this particular action, we will change the meaning. Okay, the meaning will change. So you have to change the action that you indicated. So in this particular problem, it states here that many fish are kept in many storage. So what we could do is fish or one or many fish are kept in one or many storage. Okay, we could actually do this in reverse. Now let's say for example, um, you are declaring that storage is where the fish are kept. You could declare that storage keeps one or many storage keeps one or many fish. Okay, you could actually change the verb into that particular action. Okay, the next problem we have many fishermen sells to many buyers. So many, one or many fishermen sells to one or many buyer. You could actually remove the word to here. So sells one or many. Oh, okay. Sells to. Okay, sorry. Sells to one or many buyers. So that is how you would create the whole diagram for that particular problem. Take note, you could change the action or the verb in order for you to keep the meaning of a particular statement. Okay, because if you will keep the verb and then you change the location of an entity or object, you are basically also changing the meaning of the situation or the business rule given. For our next problem, okay, this one, the first problem is a sun shines many planets. So sun, one sun shines one or many planet. You could also put shines, the word shines two here. That shine already defines the proper meaning, so this will suffice. Okay. Next problem. A planet houses many organisms. So one planet houses one or many organisms. And then last problem, many galaxy has many sun. So because we place the galaxy entity below sun, so we have to change the word that will state the same meaning. So the problem is many galaxy has many sun. So what I did was one or many sun is contained. Okay, you can put the word in. It's contained in one or many galaxies, which is basically if you will reverse the direction of the data, one or many galaxy has one or many sun. One or many sun is contained in one or many galaxy. Okay, I hope that clarifies everything. So from this particular diagram, ER diagram, we will change them into a class diagram. Okay, so for our first problem involving the fisherman, okay, I will okay, I will prepare my UML tool. Okay, okay. So here I'm using app.diagrams.net. So what I want you to get is or to go to is to the UML section on the left panel. And then from the UML section, kindly drag a class. So sample is our first example is fisherman. Okay. So fisherman. So I will change the class name into fisherman. So fisherman, take note of the symbols on your lecture that I have discussed earlier. The symbols used for fields and methods are Plus, if it is public, meaning it is accessible by other classes. Minus, if it is private, meaning it is only accessible by the class who created it. Sharp symbol is also called protected, meaning those under protected variables or protected methods can share those variables, those columns, or those methods to other subclasses that inherited from the main class, but it is not accessible from other classes. Okay, so we have plus, which is public, accessible to all class, minus, which is private, which is only accessible to the main class or to the class that created it. And then we have sharp or protected variables or protected fields or protected methods wherein they are accessible to other subclasses which inherited from the main or parent class, but they are not accessible to other class. Okay, so do not forget those particular symbols. So we will now create our fisherman class. So for our fisherman, we are declaring a public field. So let's say the fisherman has a name. The type is, let's say the type is string. Okay. And then we also have the fisherman also has an age, which is an integer. Okay. How about for the method? For our method, if we go back to our diagram, we have catch and sell. So catches fish and sells to buyer. So we could define that in our method. So catch, let's make this one private, private. And then we could declare the data type as void. Now, if you remember your programming, void is usually the data type that you give out to methods that does not return a value. It just basically performs an action. Okay, so catch and tell. Okay. Take note, we did not place an open close parenthesis here, but you could also do that if you want to. Actually, it is preferred. And then inside the open and close parenthesis, you could actually declare a particular data type if you are creating a method or an action with parameters. Okay, just like to remind you, what are parameters? Parameters are variables inside functions, okay, that you use in order for you to transmit or give data to that particular method. Okay. So for now, I will not be placing any parameter here. But if you want, anyway, if you want, cell maybe could place here uh, uh, huh? Data type decimal. Because if you are selling, you are handling out money. And then the return type, you could declare a return type of decimal also. Maybe for if you want to return if there is a change or sukle. Okay. So that is our first class. Then what we will do is to copy. Next will be our fish. Fish, we have type of fish. Then we also have price of the fish. And the data type is decimal. You could also declare quantity. Quantity. Let's say it's also decimal. Okay, I'll just adjust. Okay. For the fish, are there any methods or actions available? I think there is none. Okay, so basically we'll just leave the methods or action as blank. Okay. Next, we have the buyers and storage. Buyers and storage. So we have here buyer. Take note, should always be in singular form. Storage. Now for the storage, we have a storage name. Then maybe there's a date wherein you stored that particular item. Could also have a quantity. So we'll copy the quantity from the fish. Okay. Okay. So for the storage, of course, store. Then maybe we could define decimal for the amount that you want to store. Okay, you could even put here price, price for the storage. Okay, if you want to. For the buyer, we have a name, we have an age. Okay, could input maybe if you want an address of the particular buyer. Okay, next. Now that we have created our objects, we will now place a line that will connect them. So as I have said in my notes, for now, because we are not creating any complicated diagrams, there's no inheritance, aggregation, etc., etc. we could just make use of association line. So so that we could just define, okay, we could define the relationship between one object to another, including the plurality. So I will get the association one line here and connect them. So we will change the plurality. So one, and then here change it to many, which is asterisk. Okay. Okay. Next, another association line. I think it would be better if I just copy this one. Okay, what happened? Okay, remove that one. Okay, I'm just having trouble tightening the line. Okay, I think that will suffice. Okay, so fisherman is one or many fisherman sells to one or many buyer. So we use the symbol many. And then change it here. Okay, copy it. Okay, so there you go. Your UML class diagram from our fisherman diagram earlier. Okay. Now, if we will convert the other sample that we have given earlier, so I will just place it on the screen. So basically, this diagram, we have converted it into a UML class diagram. Now, what if we try to convert this diagram, the sun diagram, sun diagram into a UML class diagram? Basically, it is the same process. You just have to take note of course, the count, the action used, and of course, there will be changes in the methods as well as the columns or fields. So let us try to convert it. Okay. First, let us try to save this diagram. So you could actually save it into your Google Drive, OneDrive, Dropbox, GitHub, okay, GitLab, Trello, okay, as an XML file, PNG file, or an SVG file, or even an HTML file. So it depends on your particular uh, choice, if what format and what file you want it to be saved. However, it is better if you would change it, save it into the actual format supported by app diagrams, which is an XML file .drawio file. Okay, so let us try to save that later. Okay, I will copy the diagrams that we have created earlier so that it will be easier for me. Okay, so first is sun, and then planet, galaxy, organism. So sun, planet, galaxy, organism. The sun has a name. It also has an age. Okay. Planet has a name, has an age. Also, organism has a name, has a type, Mm. type. Okay. And galaxy has a name and distance in light years. Decimal. Address. If you want to, you could put an address there. Okay. Okay. For our sun, sun shines, one sun shines to one or many planets. What property do we have? Shine, one or many planet. And then one planet houses one or many organism. So we will add a method here. Houses or house is a void. House void. Okay. Okay. I think there's something wrong. Just copy another diagram. Okay. Planet has a name and an age, and method is house. Return type is void. Okay. Then we have organism. Organism name and type, and doesn't have any methods or action. One planet houses one or many organism. One. Okay. Next, for our galaxy, we have one or many galaxy has one or many sun. So we could place a method here contain. So one or many galaxy contains one or many sun, or many galaxy contains many sun. Okay. So basically that's it. That is how you would draw your UML diagram. Okay. For any questions, you can just give me a private message at our Discord channel. So please use the Discord channel. Do not be afraid to ask questions or further examples, as you are always free to ask any time of the day. And as long as I am free, I will answer your particular question. Now, before we go, because no one actually has given to me an answer on the sample question that I have posted on our Discord channel last October 22, I will try to actually create a UML diagram using the sample that I have posted. Okay, so please bear with me as we will try to create a UML diagram from the particular sample that I have posted. I'll try to show it to you. Okay. Okay. So this is the actual sample problem that we will try to convert into a UML diagram. Okay. So let us now go back to our UML. Ah, okay. So the first one that we will create is player, object player. The player has a name and say he has a life. Okay. We'll just leave the methods as is for now. We'll just create all the classes. So we also have a boss. Okay. Actually, I think we will try to make use of another type of relationship here because actually we are using two types of or we are using only one type of boss here, but it is of two subclasses, a boss and a big boss. Okay, so let us see and how we can handle that particular object later on. Then we have weapons. Okay, weapon. Weapon has a name. Weapon has a, let's say, strength. Okay, now the question is how would we represent an object that is a subclass of another object? Let's say the parent class is boss. And then we want to create a subclass called big boss, which is actually greater than the boss. So how would we represent that? So how would we do that? First, let us create the subclass which is called big boss. Okay. Then, in order for us to know, denote that it is derived or it inherits from the boss class, we will make use of this particular arrow. Basically, tells us that it extends or we are extending the class into another class. Just remove that text. This particular arrow is used for inheritance. Okay. So big boss inherits from the boss class. So basically it's that simple. So next, we will use again association. Okay. The player defeats boss. So defeat. Let's say we want a method called defeat. One player defeat one or many boss. So you can actually make use of one and then dot asterisk if you want to specify that it is indeed either one or many, or if it is many you can just use asterisk. It actually depends on the question, on the symbol that you are converting. Okay, for this instance I will make use of one dot asterisk or one or many. or you could just use asterisk if you want to. But to make things a standard, you could specify the symbol depending on the symbol or depending on the plurality used in the problem. Okay. So next is boss, one or many bosses under one or many big boss. Okay. Okay, it's under. Okay. One or many boss is under, but okay, under big boss. Boss, remove the method. Big boss, remove the method. Actually, because the arrow is pointing up, we are telling or describing that the big boss is from the boss class. Okay. So I think there will be issues here. Why? Because we cannot actually tell or we cannot say in this diagram that this big boss is coming from the parent class, which is boss, and the boss is lower than the big boss. So to better represent this one, I think it would be best if we create another class, and then because this is already big boss, we can call this as ordinary boss, just for it to be separated from the parent boss class. And then what we could do is line. Okay. Okay, so basically we are now declaring that big boss and ordinary boss comes from the boss parent class. Now, the next problem is how would you tell that the ordinary boss is under the big boss? According to the problem, one or many boss is under one or many big boss. So what we could do is handle, then close parenthesis, void. Okay. And then, okay, not use that one. So go back to station and then one or many. Okay, one or many. Okay. Ordinary boss. One or many ordinary boss is under one or many big boss. Now, take note, we use the method handle for the word is under, okay, which is basically almost the same meaning. Okay, and then this line will tell us that ordinary boss and big boss comes from the boss parent class. Okay, next we have weapons. So player equips one or many player equips zero or many weapons. Player equip, so integer equip. Why did we make integer as the parameter? I want, for example, if you have equipped number one, that is a sword, number two for spear, etc., etc. Return type is void. Okay. For this one, we will make another relation, association, One or many, zero or many. Okay. Okay. Next, one weapon, one weapon kills zero or one boss. Zero or one big boss. Have you? Ha? Hmm. Ayaw nga no. Oo. Hmm. Okay. So one weapon kills zero or one big boss. Then lastly, one remaining player gets killed by one or many big boss. I will also give this kill method. Okay, so basically that's it. Our converted class diagram. So from this one, okay, this is one or main. One that actually one or many. Okay, so this UML class diagram is derived from our ER diagram that is or that was presented earlier. Okay, thank you, and I hope that you learned something from our sample demonstration. And good luck with your exams. If you have any questions, you could just leave them in our Discord channel, and I will get back to you as soon as I can. Thank you and take care.